Okay, here are solutions to the logistic differential equation portion of your homework. So the big key to any logistic one is to put it into the form that we're used to. So it's always dy over dt equals ky times 1 minus y over L. L is the limiting capacity. The solution graph, which is the graph of y, will always look like this. Here's the initial condition. It will start concave up and then go to concave down and even out at this carrying capacity, which is L. And exactly halfway is where it changes concavity. And that's the rate at which it's increasing greatest. So that would be L over 2. So that's the most everything you need to know. So to answer this first question, it looks like it's a logistic differential. It says it's a logistic differential equation. So we should be able to put it into this form. And that should help us out a little bit. So the big thing is I'm going to make sure that this is 1. So I'm going to factor out a 200 here. So I'm going to be left with 1 over that would be 200, 2 over 21 over 10 p times 1 minus p over 200. So right now we know the carrying capacity of this function p is going to be 200. The initial condition is 25, so that's well below half of 200, so it will look like a normal logistic curve. So the greatest rate of change in students per second, which is where the derivative is at its peak, where it's increasing quickest, that's always going to be at L over 2. So half the carrying capacity, and the carrying capacity is 200. So the greatest rate of change of the number of students is when the number of students is 100. But it's actually asking for what is the greatest rate of change. So you're just going to plug in 100 for P. So that would be 100 divided by 10 is 10. Yes, times 1 minus 1 half. So it's just 10 times 1 half, which is 5. So I did that a little bit differently than the answer sheet. So number 7. Number 7 is another logistic differential equation, and this is in the form that we're used to. So we should be able to tell a lot about this just by looking at the question. So 100 or 850 is the carrying capacity. We're starting well below half of the carrying capacity at 105. So we know this is half of 850. This is 105. Which of the following statements is false? So the limit as t goes to infinity does reach the limiting capacity. So this is true. The derivative has a maximum value when n equals 105. That's false. The derivative would be maximum. It's increasing fastest at half the limiting capacity, which is 425. So that's false. I'm done. The answer is B. But let's just make sure everything else is true. The second derivative goes to 0. That's when it changes the concavity at n equals 425. That's true. That's half the limiting capacity. And when n is greater than 425, which would be up in this area, dn dt is greater than 0, which means the graph is increasing. That's true. And the second derivative is less than 0, which means the graph is concave down, which is also true. So everything other than B is clearly true, and B is clearly false, so the answer is B. So we have 3 more. I'll do these quickly here. This is a logistic equation. It's in the correct form, or the form we're used to. The initial population is 1,000, which is less than half of the carrying capacity of 5,000. So this is true. Just refer to the last question. It is always increasing because we're starting at a number lower than the carrying capacity, so that must be true. Now, since the carrying capacity is more than twice the initial condition, which is 1,000, it must change concavity. So the second derivative is not always positive. That's false. So circle all the statements that are true. That would be A and B. Number 9. Now this one is a little bit different. The number of antibodies in a patient's bloodstream is increasing with which could be the following equation. So we have to make sure that these equations produce a logistic situation. So when I'm seeing the antibodies, it would be dy over dt. If it's logistic, it would be in the form ky times 1 minus y over L. So we just have to figure out which one of these equations are in that form. Obviously, no. Obviously, no. This would have to be a y. It's not with respect to t, so that's obviously not. It's between d and t. What's the difference between d and t? Well, this has a k times a y. For D and E, I'm sorry. So this is the form of a logistic differential equation. That's pretty simple. If you want to put it exactly in this form, you just divide or factor out 5,000. So that was pretty easy. Finally, question 10. Question 10 is just like question number 10. So these are actually a little bit too easy, I think. The one in the form of a logistic differential equation, we're doing it with respect to y, so this would be a y and this would be a y. Don't get tricked with these t's out here. That's kind of too easy. So the answer is E. So hopefully, those are actually pretty simple. So hopefully you had no problem with them. That's it for me. I'll see you next time.